Number 59. For the following exercises, write the equation for the graph function. Now, what I did with these is I found the vertex. They're nice integer coordinates, and I also found another point on the graph. You know, it's reminiscent of the problems we were just doing. So if you get the vertex and another point on the graph, and that's your choice, I would choose a point with easy numbers to work with, easy integers if possible. And they've purposely made these easy to see, alright, and that way you can do these problems pretty readily. So here are my 2 points for this graph. You can see marked on there. So we have 2 known points. Vertex HK is equal to 2, -3. And we also have a point 0, 1. I'll just label that VHK, alright, call that the vertex. Now, the graph, as you saw, opens upwards, so the leading coefficient A in the standard form is greater than 0, right? It's positive. So, use the standard form, f of x equals A times the quantity x minus h squared plus k. Alright, so this is xy in the formula, and this is hk. Alright, so we've got 1. You let y equal f of x also, like we did before. So we have 1 equals A times the quantity 0 minus 2 squared minus 3. Alright, so we have 4 here, and you can add 3 to both sides, so you get 4 on this side, so you get 4 equals 4a. So a must be 1. If you came up with a negative a, then you know you got it wrong somewhere, because we already know that a must be positive. It does open upward. Alright, so therefore f of x is equal to, using the standard form again, x minus 2 quantity squared plus, or rather, a minus 3. Alright, so you can expand this, get it into general form, x squared minus 4x plus 4 minus 3. So finally, x squared minus 4x plus 1 is the general form of this function. Number 61. Here's our graph, and the points that I've picked, you want the vertex and another point, preferably one that's easy to work with, like one involving zeros like I have here. You can pick other points if you wish, but make it easy on yourself. That's the wise way to do this. Okay, so we have vertex HK is equal to 2, 7 and a point 0, -1 on the graph. And the leading coefficient A is negative. It opens downwards, so we know A is going to be negative. So we have our standard form, f of x equals A times the quantity x minus h squared plus k. So plugging the things in and letting y equal f of x, we've got negative 1 equals a times quantity 0 minus 2 squared plus 7. And so we add or subtract 7 for both sides, so you get negative 8 equals, and 2 squared is, negative 2 squared is 4, so that's 4a. Divide both sides by 4, so you get a equals negative 2. Negative as we thought. Alright, so therefore f of x is equal to negative 2 times the quantity x minus 2 squared plus 7. Alright. And this is equal to negative 2. We can expand that. X squared minus 4x plus 4. Oops. Not plus 4x. X squared minus 4x plus 4 plus 7 outside of the parentheses there. And so this is equal to negative 2x squared minus 4x. We can bring that 4 out, multiply it by negative 2 first, and then add it to the 7. So negative 2 times 4 is negative 8 plus 7. Alright, so we end up with distributing that negative 2 through, negative 2x squared minus or plus and 8x and then minus 1. Number 63. Here's our graph with points picked. So you need again to find the vertex, and then you need another point on the graph. That's your choice. So mine was 1, 1. Alright. So we have our vertex, call it V, HK. And that's 3, negative 1. And another point on the graph, 1, 1. So the leading coefficient, it opens upwards. A has to be greater than 0. Alright, so f of x equals a times the quantity x minus h squared plus k. So let y equal f of x, and then we plug in the numbers. 1 equals a parentheses 1 minus 3 squared minus 1. So we end up with adding 1 to both sides, 2 equals, and this is negative 2 squared is 4, 4a. Divide both sides by 4, and so you get a equals a half. Positive 1/2. Alright, so that means, therefore, f of x is equal to 1/2 times the quantity x minus 3 squared minus 1. And we can expand what's in the parentheses, 1/2, and that gives us x squared minus 6x plus 9, and minus 1 outside the parentheses. We can bring that 9 outside, multiplying it by 1/2, and then you can add that to negative 1. So you've got 1/2 x squared minus 6x, and then you've got plus 9 over 2 minus 1, which is 2/2. So distribute that 1/2 through, you get 1/2 x squared minus 3x, that would be 1/2 times negative 6x, and then plus 9/2 minus 2/2 is plus 7/2. Number 65. For the following exercises, use the table of values that represent points on the graph of a quadratic function. By determining the vertex and axis of symmetry, find the general form of the equation of the quadratic function. Alright, so here's our table. And what I did was I took those points and plotted them. And then it was easy to see what the vertex was. And then find another point on the graph, which is given, actually. It's pretty easy. And then it's a lot like the problems we were just doing. Okay, so here's the graph that I made of just the points they gave us. Right there. So I used my computer and just plotted points. You could do that by hand pretty easily using graph paper. So you can see the vertex, and I picked a point there, 1, 2. You can pick any other point. And there you go. So we've got the vertex, v of hk, is equal to 0, 1. And we have a point picked, 1, 2. And it's pretty clear, a is greater than 0. It obviously opens upward. So we have standard form f of x equals a times the quantity x minus h squared plus k. And so let y equal f of x, as we usually have been doing, and then let plug in all the values that you have. 2 equals a parentheses 1 minus 0 squared plus 1. And so 1 squared, subtract 1 for both sides, you get 1 equals, and then 1 squared is 1, so that's just a. Well, that's solved for us right away. So therefore, we have f of x is equal to x minus 0 squared plus 1. And that's just x squared plus 1. That's already in general form. So that takes care of that. Number 67. So we have our table there, and you can plot those points, and here's what I came up with. So it's easy to see, it's a graph opening downward, and there's your vertex, and I picked the point 1, 1. You can pick any of the other points if you wish. And so we have vertex v of hk is 0, 2. And I picked point 1, 1. So we also know that a is less than 0, a is negative, opens downward. So f of x equals a times the quantity x minus h squared plus k. There's your standard form. And let y equal f of x, and then plug in xy and hk in the formula. So you get 1 equals a times parentheses 1 minus 0 squared plus 2. So you end up with negative 1 equals a. Alright, so therefore f of x is equal to negative, and then you've got x minus 0 squared plus 2. And that will simplify to negative x squared plus 2, which is already in general form. So there you go. Number 69. So here's our graph. Well, here's the points they gave us. And plotting those points, you get this. Let's see if I can get it all in there. You can see the vertex is 0, 0, and I picked 1, 2 as our point. And so the vertex v of hk is 0, 0. And we have a point 1, 2, which I have picked, but you can pick any other of those points except for the vertex. And the graph opens upwards, so we know that the leading coefficient a must be positive or greater than 0. So standard form f of x equals a times the quantity x minus h squared plus k. So we've got let y equal f of x, and then plug in our values. We've got 2 equals a times the quantity 1 minus 0 squared plus 0. So that means a equals 2. So therefore f of x equals 2 times the quantity x minus 0 squared plus 0, or 2x squared, and that's in general form. Number 71. For the following exercises, use a calculator to find the answer. And then it says graph on the same set of axes, f of x equals x squared, f of x equals x squared plus 2, and f of x equals x squared, f of x equals x squared plus 5, and f of x equals x squared minus 3. What appears to be the effect of adding a constant. Alright, you don't need a calculator to tell you this, or to give you the answer. We've already covered this in transformation of functions way back in the old days, right? So what you get is a vertical shift when you add a constant. This is something we know from transformation of functions. Let's use y equals x squared plus 5 as an example. If I subtract 5 from both sides, y minus 5 equals x squared. Y minus a constant. That constant is going to cause a vertical shift. It's next to the y-axis, think vertical axis. So vertical shift, okay, and it's going to shift upwards by 5 units. All right. What's going to shift upwards? Y equals x squared. Okay, so you take y equals x squared, which it has a vertex at 0, 0, and you shift it up 5 units. Okay. What if the 5 was inside that x there? What if you had this? Y equals, oops, y equals x minus 5 squared, like that. Well, that x minus a constant, that constant is going to cause a horizontal shift. Think horizontal because it's next to the x. Think x-axis is horizontal. Alright? And so it's going to be x minus the constant, which is a positive constant, and that's going to go to the right 5 units. Okay. If that were a negative 5, it would be x minus a minus, which is x plus 5. And a negative 5 would cause a shift to the left. Same here. If this were minus, that would be minus a minus 5, or y plus 5, and that would be a shift down. Okay, this is a shift to the right, and so that will be 5 units. So you take y equals x squared, which looks something like this, and you move it to the right 5 units. Okay, so it'll be over here somewhere. So that's following the what we have already learned in transformation of functions. Okay, but I did use a computer to graph all of these that they asked us to graph, and you can see all together on the same set of axes these shifts going on. Right there. And I've labeled each graph with its formula. So there she is, right there. Okay, number 73. The path of an object projected at a 45-degree angle with initial velocity of 80 feet per second is given by the function. Let's see, we've got h of x is equal to negative 32 over 80 squared x squared plus x, where x is a horizontal distance traveled and h of x is the height in feet. So basically looks kind of like this. So we have an object being fired, or that's what I'm thinking of. Something is propelled somehow at a 45-degree angle, and the speed coming right from the start is 80 feet per second. And we're getting a parabola with a negative leading coefficient. Doesn't matter what it is right now. So we know it's a parabola that opens downward, and we know when x equals 0, this whole thing equals 0. H of x equals 0. So it starts at the origin and it does something like this. We don't know where that point is, but it probably doesn't matter on this one. So that's basically what it looks like. H of x would be the height, and the horizontal, and x is the horizontal distance, right? In feet. All right. So use the trace feature of your calculator to determine the height of the object when it has traveled 100 feet away horizontally. Okay. Well, you know, you could just take h of 100. All right, let x equal 100, plug it in, and you can figure it out that way. Okay. But what they want you to do is use your trace feature on your calculator. All right, so what it's going to do is find out where the point is on this parabola when x equals 100. So you would, manipulate that. Well, what's the viewing window? I would like to know. I'm not sure what the viewing window is, but why don't we find the vertex, and that'll give us an idea. It'll be a nice, interesting exercise anyway, finding the vertex. It'll involve a little bit of algebra here, so if you're allergic to that, you might want to turn away and fast forward. Alright, so let's complete the square on this. Let's see what happens. Alright, so we've got negative 32 over 80 squared, x squared plus x. That equals negative 32 over 80 squared. And then I'm going to factor out negative 32 over 80 squared from these two terms. Alright? You're saying, holy cow, what happened here? Don't worry. Don't worry. Alright, so we've got x squared minus 80 squared over 32. X. I just inverted this, alright, and when you multiply these two, what are you going to get? You're going to get a 1, right? So that's what you have here, 1x. And negative times negative is positive, so it's going to be what we wanted. Alright, so that wasn't too bad. Now we're going to take half the coefficient of x and square it, and then add and subtract that number inside the parentheses. Alright, so let me do that by separating all of this with a line, because I need the space for showing my work here. Alright, so I'm going to take half the coefficient of x. What is that? That's negative 80 squared, right over here. Negative 80 squared over 32. And then we're going to square that like that. So what do we get? We get, multiply half times that, you're going to get negative 80 squared over 64. And then we're squaring that. Alright? And 80 squared squared is 80 to the 4th. And 64 squared is 4096, and when you square a negative you get a positive. So you're going to get 80 to the 4th over 4096. And this comes out very nicely. When you just punch that into a calculator, you should get 10,000. That's not bad at all. Alright, I thought it was going to be pretty nasty. But no, it's not too bad. So let me put another line here separating the scratch work. Alright, now we'll get back to this. So I'm just going to carry on from where this to the right of the equal sign here. So equals, alright, negative 32 over 80 squared. And then we've got all of this, and then you're going to add and subtract 10,000. So you've got x squared minus 80 squared over 32x plus 10,000 minus 10,000. Okay, so that's equal to negative 32 over 80 squared times x squared minus 80 squared over 32x plus 10,000. And now you're going to take that minus 10,000 out of the parentheses, but first you have to multiply it by the negative 32 over 80 squared. And it also works out to be very nice. When you multiply this times that, you end up with a plus 50. Alright, so that's negative 32 over 80 squared and then you've got x. This is a perfect square trinomial right in here in the parentheses. You got x minus, take the square root of that, or half of this, but it's easier just to take the square root of that. That's 100. Square root of 10,000. Alright, x minus 100 squared plus 50. And so the vertex V is equal to 150. Well, look at this. This when x is 100, then the height is 50. That's the answer to our question right there. It's at the vertex. It's at the highest point of the trajectory of this object, or this projectile, whatever you want to call it. So we've answered the question, haven't we? You know, if I were writing this problem, I'd say, what's the height when x is something either to the right or left of 100? All right, but I didn't write it, so there we go. Okay. Well, what's a viewing window? You know, if that's right in the middle of the parabola, let's try this viewing window going from 0 to 200 for the x values, and from 0 to 110, let's say, because the highest point is 100. So if I put 110 for the y values, that'll get everything in the graph, everything in the screen. All right. So here's my graph, and it's already got the answer on it right there.